Hi guys, let's come to the fundamental theorem of calculus part 2. So last time we mentioned this kind of formula, and then this time we're gonna mention this the definite integral from a to b fx dx can be found by using the antiderivative fx, capital F of x, and then you substitute the upper bound and lower bound and just subtract this from f of b, and that's gonna be the area under the curve lowercase f of x from a to b, right? So we can find the area by using the antiderivative. That's it. Now let's come to the examples and see how it works. The first example I'm gonna show you is quite simple. So let's take a look at this function gx equal to x squared minus 2x plus 2. And then we're gonna find this from 0 to maybe 1 gx dx. So just plug in, right? 0 to 1. Plug in here. X squared minus 2x plus 2 dx. Since we're using the part 2 of the fundamental theorem, so we're gonna find the antiderivative of this function first. So integrate this function, and then we're gonna use the upper bound to minus the lower bound here. So it's gonna be integration of this function, which comes to 1 over 3 x to the 3, right? That is the integration, the antiderivative of the first term. And then for the second term, it's gonna be x squared. That's antiderivative of 2x plus 2x, right? That is the original function or the antiderivative. And then we write this symbol, means that we use the upper bound to minus the lower bound. So you're gonna plug in this upper bound there, which is gonna be 1 over 3 times 1, right? Minus 1 squared is 1 to the third, minus 1 squared, plus 2 times 1. That is our f of b. And then you're gonna plug in 0 in here, which is gonna be our f of a. So it's gonna be 1 over 3 times 0 to the 3 minus 0 squared plus 2 times 0, which is just 0. So we have our final answer, 1 over 3 minus 1 plus 2, which is 1 over 3 minus 1 plus 2, and it's just 4 over 3. Very simple like that. So I'm gonna show you the other example which require another method. So let's erase this. Now I'm gonna change the function to gx equal to square root of 4 minus x squared, and then I'm gonna change the lower bound here to -2 and the upper bound here to +2. So it's gonna be like this. If we want to use the previous method to find the antiderivative of this function, it's gonna be tough because you have 4 minus x squared under the kind of square root. If you look at the list of your integration, that kind of formula sheet, you don't see such a formula for this kind of function, right? So that will let us think about the original definition, right? Which is, this thing means the area under the curve from the interval a to b. So we are gonna think of the kind of the area enclosed by this curve from -2 to 2. So actually what this curve is, if you look at this curve, if you set y equal to 4 minus x squared, and then if you square both sides to get rid of this square root, you're gonna have y squared equal to 4 minus x squared, right? This thing gives you this. And then you can move the minus x squared term to the kind of left hand side. So you have x squared plus y squared equal to 4. This thing. So the curve given here, this function, is actually a part of the circle having the radius 2, which is x squared plus y squared equal to 4. So we can grab this circle. So it's like this circle. It's 2 here, -2 here, right? This circle has radius 2. But it's not the entire circle, because the square root here only gives you the positive part of the curve. So it means that the lower part, the negative part of this curve, is not included. So you only have actually the upper circle here. You don't have the lower circle, right? The upper circle is the curve given here, because the square root always means positive, at least non-negative thing. Then followed by the definition, this integration, definite integration, is gonna be the area under the curve from -2 to 2. So it's gonna be the area of this kind of half circle here. Since we know how to find the area of a circle, right? So we know how to find the area of half circle. It's just 1/2 times pi r squared. So we can find the area very easily by using the formula. It's going to be half of pi r squared. And now the radius r is just going to be 2 times 2 squared. So we have 1/2 times pi times 4, which is 2 pi. Right? So we find the area here, just 2 pi. That is by using the definition of integral, not actually finding the antiderivative of this function. So I hope these 2 examples will help you. And then if you still have questions, let me know, and I will try to make a video to explain that. And thanks for watching.